Okay, here we have a problem that says use transformations to graph each function. Determine the domain, the range, and the horizontal asymptote of each function. So we have this one that says 2 raised to the x plus 2 power. Well, because our base is bigger than 1, we can expect that this graph is going to be an increasing function. We can also expect that because we know some properties of the exponentials, if you'll remember, you had those 3 special points that were on here. We had the point 0, 1, the point 1, comma a, and the point negative 1, comma 1 over a. Well, our a value here is a 2. This would help me to be able to graph the graph of y equals 2 to the x, which is our kind of our base function. We talked about those when we did transformations before. We started with a base function and then we did translations to move it around a little. So my original base function would look like this. It would have the points 0, 1, 1 comma a, which in this case would be 2, so 1 comma 2, and the point negative 1, 1 over a, so negative 1, 1 over 2, which is 1/2. So my original function looks something like that. That's kind of a crude drawing. I know it's not completely exact, but it gives me an idea of what it would look like. Okay, now here's where the translations or the transformations come into play. Do you remember what happened whenever we had something like a plus 2? With x, inside with x. Remember, outside move things up and down. Inside with x move things left and right the opposite direction. So this plus 2 is going to take that function and scoot everything over to the left 2 units. So my point here is going to go 2 units to the left. This point is going to go 2 units to the left. And this point is going to again go 2 units to the left. So my graph is going to look something, like this. This would be the graph of y equals 2 to the x plus 2 power. Now, talking about the domain, the range, and the horizontal asymptote. Again, you have to know the properties of the generic exponential. The domain is the set of all real numbers. Well, whenever I moved it over 2 units, that doesn't affect the domain, does it? If it's all real numbers, then scooting it over 2 units, it will still be all real numbers. What about the range? Remember, the range of the exponentials is 0 to infinity, all positives. When I scoot it over 2 units, that does not affect the range again. It is still going to be 0 to infinity. Now, if I had moved it up, that would have affected the range. So use those translations and your knowledge of the properties to help you figure out what's happening with the domain and the range. And then finally, our horizontal asymptote here. Our horizontal asymptote in the properties of exponentials said it was the x-axis. Well, again, moving 2 units over to the left does not change that horizontal asymptote. So that is still going to be the x-axis, or y equals 0. But again, if I had moved it up, it would have affected the asymptote. Now, we're done with this problem, but because we have these beautiful calculators, I want to show you that you can double check yourself to make sure you're correct very quickly and easily. Here I've already typed in for kind of time's sake. I graphed my original 2 to the x and then the 2 raised to the x plus 2. So whenever I graph this, our original function, 2 to the x, looks like this. That looks very, very good for what we did on our paper. And then the new one is been scooted over just about 2 units. So we have a visual on ourselves.